So now we're going to use the last dollar rule to answer the question, how does a firm adjust its optimal input selection if wages change? We'll go through both cases. The first case, what happens if wages were to drop? So initially, the optimal bundle is point X before wages change. And look at cost minimization part 1, part 2, or part 3 for an in-depth look at how we come up with X as being the optimal bundle, the tangency point of the isocost and the isoquant. At this point X, we know the slopes are equivalent. And so the last dollar rule indicates that this ratio of NPL over W is just going to equal the NPK over R. Now along comes a drop in wages. So the downstairs over here has gotten smaller. The denominator has gotten smaller. So this overall number now has increased. This side, the right side, has not changed, but the left side has gotten larger. So what does that mean? Well, what that means is this NPL over W is now greater than NPK over R, or one more dollar spent on labor will provide a larger increase in the marginal productivity than one more dollar spent on a machine. So what should firms do? Spend more on workers. Makes sense, correct? If wages drop, workers look like a better value to the firm. And so what happens? This isocost curve now gets flatter, because recall the isocost curve has this slope that's negative W over R. And wages just dropped. So this slope has gotten smaller. Now here's the new slope. Isoquant didn't go anywhere. It's still the same shape. But we simply move along the isoquant, and now we want more workers. Instead of 50, now the optimal number is 77. And now we want fewer machines. Instead of 100, now the optimal number of machines is 52. And this is our new optimal bundle, bundle V. So when do you stop? When is this no longer the case? At point V, it's no longer the case that NPL is bigger than W. At point V, now this last dollar rule says these two are equivalent. NPL over W just equals NPK over R. Anywhere past this point, then NPK over R will be larger than NPL over W, which says, hey, we need more capital and less machines. So this is the optimal way a firm adjusts its inputs if there's been a decrease in wages. Now, I want to go through one more case with you, and that's the opposite scenario. What should a firm do if wages have gone up? And with the pandemic, Walmart has gone off and paid workers at least $1 more per hour, effective as of September 25th, 2021. They raised their pay for hourly workers, more than 500,000 workers, by $1. So if wages now are going up, how does this impact the optimal combination that we had before? Well, if wages are higher, then that's going to impact the optimal input combination. So what we're going to see is companies, if you've got to pay an employee more, are going to substitute more machines and hire fewer workers. So you have one employee in charge of multiple self-checkout machines. Use machines to replace employees. And so that's what we're seeing here. The last dollar rule tells us again that the NPL over W must equal NPK over R at the optimal. Well, if you raise workers' wages by $1, this side has gotten smaller, the left side. The right side didn't change, so now it looks like capital is a better value. So this says, hey, adjust your capital spending so you spend $1 less on a worker, $1 more on capital, and you can get a better value for an additional increase in output. So that's exactly what Walmart does. They pay their workers more, They use more machines, more capital, and fewer workers now for the optimal. And there's what this answer here says. Look at your ISO cost line. If you pay your workers more, that line's gotten steeper. So workers are more expensive. ISO quant didn't change. So this is just the opposite of what we found previously. The optimal bundle now will be up here if we have to pay our workers more and we pay our machines the same amount. Okay? So that's how you answer the question if wages were to go up instead of going down.